In the previous video, we have learned how to calculate the molecular masses of compounds. Alright, so here let's move into the mole as a unit. Alright, so we define the mole. So the mole is defined as the amount of substance that contains as many elementary units as there are 12 grams of carbon-12 isotopes. So here the elementary units may be atoms, ions, molecules, electrons, protons, neutrons, etc. So here when we talk of the atoms, for instance, if you have, let's say now the unit measurement for mole is what we write it as mole. This is the unit of it. So for instance, if we have 1 mole of hydrogen atom, now this 1 mole of hydrogen atom is also equivalent to what 1.0 gram, that is its relative mass. So 1 mole of hydrogen always gives us what 1 gram here, and then 1 mole of, let's say, sodium atom is also going to give us what 23 grams, because the relative atomic mass of what sodium is 23. 1 mole is equivalent to that 23 here. So we do this, or we do this equations to just show that every amount of substance that can contain 23 grams of sodium has 1 mole, right? Alright, so each mole of sodium contains 23 grams. Each mole of hydrogen contains 1 gram. So that is how we do them. Alright, so let's see for the molecules. Assuming we have the molecules, let's take the molecules as well. So for the molecules, we know that 1 mole of H2, that is H22, that is the combination of 2 atoms of hydrogen. So because 1 atom of hydrogen, or 1 mole of hydrogen atom is 1, if you take H2, we have to get 2, because these 2 will multiply it with relative mass, as we were using to calculate the relative molecular masses of it. Alright, so here 1 mole will be also equivalent to the relative molecular mass of every compound. Right, so this molecule O2 here gives us 32 grams, and then 1 mole of sodium hydroxide NaOH is going to give us 40.0 grams. Alright, so this tells us that thus every 1 mole is giving us the relative atomic mass per the molecular mass, right? So let's note that the number of atoms present in the 0.012 kilogram or the 12 gram of carbon-12 isotope is 6.02 times 10 to the raised to the power of 23, and it is called the Avogadro's number. So the Avogadro's number with this symbol L. Alright, so it means that 1 mole of carbon-12 contains 6.02 times 10 to the power 23 atoms. So it's the same thing here. If you take 1 mole of hydrogen atom here, which is equal to 1 gram here, is also equivalent to 6.02 times 10 to the power 23 atoms, as defined by the Avogadro's number. Alright, so it means that 1 mole is equal to, or is equivalent to, the relative atomic mass per the molecular mass, and which is the same as the Avogadro's number. Alright, so that is the relationship. So any 1 mole of a compound is equal to 8 relative atomic mass or 8 molecular mass, and is the same as what the Avogadro's number. Alright, so with a quick one, let's move on to the molar volume. I'm defining the terms for you so that we can easily work our moles. So molar volume. So the molar volume occupied by what 1 mole of a gas at a given temperature and pressure, which is called the standard temperature and pressure, that's STP. So the volume that is being occupied by 1 mole of what a gas at a given temperature and pressure, which is called the standard temperature and pressure, that is STP. So 1 mole of a gas occupies a volume of 22.4 decimeter cube. So each mole of a gas always occupies 22.4 dm cube or decimeter cube of that particular compound. Alright, so this volume is called the molar volume at STP, which is written as the V or M to the power of theta. Alright, so that's the molar volume at STP. So the standard conditions, remember we are saying it is when they are under our standard temperature and pressure. So the standard conditions here are temperature, we need to get 0 degrees Celsius or 273 Kelvin, and then the pressure to be 1 atm, that's the atmosphere, or 10 to the power 5 Newton per meter square, or the Pascal, or we take 760 millimeter of mercury. Alright, so example here is let's take from the beginning. The first example, 1 mole of H2 gas, this time around is what a gas, is giving us 2.0 grams, of which we are aware of it, and then it's the same as 6.02 times 10 to the power 23 atoms, molecules, sorry, this is a molecule. Alright, and then this is also equal to 22.4 decimeter cube, because every 1 mole of a molecule or a compound of a gas gives you 22.4 dm cube at standard temperature and pressure, so at STP. Alright, so it means that 1 mole is equal to the relative atomic mass or 8 molecular mass, which is the same as the Avogadro's number, which is also equal to the standard temperature and pressure, that is the molar volume. Alright, so this is also related. Alright, so in view of this explanation, in our next video we are going to deal with the calculation of a mole. So viewers, thank you for watching this video, and please don't forget to share this video to your friends and also subscribe, so that if whenever we upload a new video you will be notified. Alright, so thank you for watching.